Hi everyone, welcome to HasuraCon 2023 and hope you are just like me soaking in all the new and exciting development in the GraphQL space and with Hasura as a platform. My name is Rajat and I lead the customer engineering team at Google Cloud. We are a team of solution architects that help our customers get value out of Google Cloud by ensuring right architecture, tool, and platform is adopted for the right use case. In the next 30 odd minutes, I'll be covering how you can unlock some immense value out of Hasura and GCP combination. And also talk about some of the capabilities of GCP that complements Hasura's ability to be able to make access to data simple, secure, and reliable as well. So, let's start with the basics, right? How do you get Hasura working on GCP? And that's surprisingly simple. It's almost like a match made in cyberspace. There are actually two ways of doing that. In fact, actually, there are three ways, but let's just talk about two for now. The first option is to use Hasura Cloud. Hasura Cloud, as you probably already know, is a fully managed version of Hasura's popular open source GraphQL engine that gives you the scalable, highly available, globally distributed, secure GraphQL API over data sources. Hasura Cloud has done a fantastic job of taking care of all performances, security, reliability requirements over the API layer. And launching this in GCP is also pretty straightforward. So you select your favorite cloud provider, of course, GCP, and from the list of the drop-down and choose the region closest to your users and follow the instructions. And within a few minutes, you would have a highly scalable instance of GraphQL available on GCP to configure and serve your customers. However, there is also another option in case you want to manage the life cycle of Hasura yourself. It's called Hasura Enterprise. And this edition has capabilities of observability, security, GCP's Cloud Run feature itself, right? And it's as simple as 5 easy steps. The first one is download the manifest file, basically the YAML files associated with it. Second is configure the required databases with a few commands, store the metadata, cache, secrets, etc. Obviously, update the license information in the configuration file. You obviously need to also push the Hasura container image to make it available in the GCP image registry. And finally, launch the instance with a single command. That's it. And the detailed instructions are available in the blog post here. And oh yes, there's one last thing. If you're already using Google Identity or Workspace, you can also hook that up to Hasura as well, making the authentication to the backend seamless. Right? So that's really how you get started. And with that out of the way, good to talk a bit more about what's so special about Cloud Run. Why did I pick Cloud Run over other options available? Allow me to explain why these three things make Cloud Run so special. First one is Cloud Run charges you only for the resources that you need, and hence the name serverless. And if you're focused on new product market fit, the free tier is just the right fit for you. The pricing is based on CPU, memory, time dimension, basically the resources you need to execute a request. We provide 180,000 vCPU seconds per month and about 2 million requests per month in the free tier itself. That's a lot to validate if what you're building has legs. So, beyond the free tier, for the requests that are coming to the instances, they are rounded up to the nearest 100 milliseconds. So you really end up paying for what you use, especially for very low latency request response cycles. That's a great option to start with. The second point is about how the billable CPU allocation is calculated. By default, Cloud Run only charges you for CPU and memory allocated to an instance when either the instance is starting or shutting down, or at least one request is being processed by the instance. Billable instance time begins from the start of the first request to the end of the last request. And if you're concerned about spiky traffic, you can increase the number of instances ready to serve the traffic. However, here's the best part. You will be billed at a different idle rate for those instances that are not serving traffic. Then there is always the allocated mode as well, which in this mode is useful for running short-lived background tasks and other async processing tasks. With this, you'll be billed for the entire lifetime of the instance from the time the container is started to when it is terminated with a minimum of 1 minute. But even in this mode, we ensure that there are no underutilized resources, and auto-scaling can still terminate instances if they're not handling any incoming traffic. An instance will never stay idle for more than 15 minutes after processing a request. Of course, unless you enforce a minimum number of requests, number of instances to be present. So it really ensures that you pay for the duration of serving the request for a given instance and further optimize it. You can also trigger that through the command line as well by ensuring that there is no CPU throttling, so the server instances are running all the time. Now, continuing on that thought, one of the biggest challenges of serverless paradigm is the cold start problem. Every time you serve a request, you need to spawn an instance when it can't handle any more concurrent requests, as serverless infrastructure does. This causes increased latency, also referred to as a cold start problem. Cloud Run provides you the capability to provide the minimum number of instances you want to run to ensure that you can avoid that. But unlike other approaches, we ensure that you're not penalized for having some instances still waiting for serving some requests. In fact, we only charge you 10% of the cost. So for a small cost, you can actually totally avoid the cold start problem and create great customer experiences at an overall low cost. And now the third and the last point on Cloud Run, right? Each instance of Cloud Run can handle multiple concurrent requests or connections. But once it exceeds the number of concurrent requests, then it spawns another instance to scale. And that's really what the magic of Cloud Run is. However, the number of instances that gets created as a result has an impact on cost. Now, let's look at it from an example point of view. The green line that you see in the graph is the number of requests for a deployment configured to handle only one concurrent request, for instance. In real world, obviously, we won't do that, but this is more illustrative. The blue graph at the bottom shows the number of instances created to handle the requests, given each instance should only handle one request at a time or handle one request at a time. However, when we take the same system and configure it to increase its ability to handle higher degree of concurrency, we look a very different picture. In this example, we've changed it to handle 80 concurrent requests at a time. And so it needed a fewer number of instances, and hence a much flatter blue graph for the same number of requests. Now, this is a huge cost impact, reduces your cost significantly. And what if I told you the concurrency can be increased to a maximum of 1,000 requests per instances? Isn't that mind-blowing? That's really the amazing scale at which it can operate. So you can work out the maths of how cost-effective this approach overall can be. Obviously, you need to ensure that your code can handle concurrency at that scale, and that includes applying all the usual best practices like avoiding global state variables, dependency on storage, reducing the number of libraries to load in memory, etc., etc. So the usual stuff applies. And one last bonus idea. I said 3 ideas. There's one more that I want to talk about, and perhaps the most useful bit for engineers: the ability to know when the serverless is going to take the compute away. This is where a lot of first-time serverless applications get into trouble. It is important to be able to know when the serverless compute is going to go away, so that you can do the required cleanup to ensure other dependent systems are not left hanging, like file descriptors and database connections, etc. So we do issue the SIG term that can be captured in the code and handled, and you can take the appropriate action around it. So you can see why Khan Academy, a non-profit organization with the mission for providing free world-class education, chose to use Cloud Run. Their website actually runs in 36 languages, and 18 million people learn on Khan Academy on a monthly basis. But before they were using Cloud Run, they could only handle up to 2,000 concurrent views. But with these capabilities, they were able to focus on product development and not worry about scaling and ensuring that it is happening at a viable cost itself. And you can see why that was the case. So Cloud Run isn't just used for building a GraphQL API endpoint, a public website. It supports gRPC as well. So you can use it for building private connections, making it talk to internal APIs, and also you can use it to deploy jobs, building event-driven architecture-based applications as well. So it is fairly versatile in that sense. So now that you have Hasura working on GCP in a cost-effective and a scalable way, what next, right? How about access to some data sources, but not just any data sources? Let's talk about what we have for you in GCP, right? And it's an interesting section. So at Google, we're very familiar with this issue of creating value from data. We have a number of products in which we have turned data into improved experiences for customers by using artificial intelligence and analytics. This data foundation is what has allowed us to bring simplicity to a complex and sophisticated world in a limitless data infrastructure. So you may ask, how can I run like Google too? How can my data cloud also work with the same design principles of limitless scale, limitless workloads, and limitless users as well, right? And that's really, when we talk about BigQuery and BigQuery comes into play, It is one of our petabyte scale data warehouse solutions. And I'll talk more about the features in a few slides. But really what I want you to understand is from storage to compute to networking, BigQuery is designed to bring all of Google's innovation and resources at services to your query. So let's just look at some of the features of BigQuery itself to understand why this could be a great backend to connect Hasura with. For starters, BigQuery architecture is unique in the sense that the storage and compute scale independently, and that massively simplifies the process of working with data. This segregation ensures that you don't have to worry about capacity planning, cluster sizing, optimization, and administration. BigQuery is designed for you to freely work with data of any type at any scale. So, we just call it just add data attitude when we're using BigQuery itself. BigQuery also has one of the widest and deepest support for data of all data types in all types of structured, semi-structured, JSON, geospatial, all data formats. And that really makes it fairly versatile because the more data we support within the system, the easier it becomes for you to innovate around it and build new experiences with API layers that you can build on top of it. Also with BigQuery, you can build end-to-end real-time system for real-time ingestion and real-time analysis. BigQuery has a streaming API and integration with PubSub, our messaging system, and Dataflow, which is our batch and streaming analytics processing tool, including a BI engine tool. BigQuery BI engine is our in-memory analysis service, which will let your users analyze complex data set at high concurrency at a sub-second query response time. Now, imagine the kind of queries you could do with something like this and make available to your front end via GraphQL. And beyond unifying batch and streaming analytics, we've also dramatically simplified bringing in machine learning to the data landscape. BQML allows you to provide and define your ML models as first-class citizens to be queried like any column in your SQL query. In the GraphQL context, this would have otherwise be two separate calls, one to the database and one to the inference API, and then combining them before it can be served to the end user. And while accessing the output of the model is as simple as executing a query, training the model is also just as simple, using a select query to define the training sample. With BQML, this is literally no data movement, no new infrastructure required for both training and for inference. It's just like a first-class citizen call. And BQML comes with a lot of predefined models as well, so it doesn't take too much of an effort to get started. But we also have the options for you to bring in your models from outside. So how do you connect to BigQuery? It is as simple as selecting BigQuery as the data source and doing the required configuration. And it can build out GraphQL schema based on what it sees in the BQ dataset and tables. More on the integration, permission configuration, etc., please look at the documentation link that you can see on the slide. But this was great. But do I hear you say BQ is a data warehouse solution? This kind of integration would be ideal for internal applications, dashboards, reports, etc. What about building experiences for large-scale audiences using an OLTP database that is fast, open source, and reliable? GCP has a range of databases in that space, but today I wanted to pick our newest addition in the portfolio, AlloyDB, as it's one of the most exciting databases, one that takes the benefit of the familiar open source interface for Postgres and machine learning driven innovation to manage databases at scale, providing you the peak performance. So we started with Postgres as it's the world's most loved relational database. We took that as a starting point and added elements of what we know best. So we added cloud native architecture that disaggregates compute and storage to achieve higher scale, performance, and availability. We also use the awesome engineering team assembling the database experts across the industry to learn what's the best way to build this. And our DNA of AI/ML to make everything about running the database much easier. And the benchmark numbers look great too. AlloyDB is 4x faster than your standard Postgres for transactional workloads. It is also more than 2x faster than next in competition cloud providers comparable PostgreSQL, compatible for transactional workloads. This means you can scale transactions well beyond previous limitations and get better performance out of fewer resources and much smaller database instances, further reducing your cost of running this. And best of all, query performance scales linearly as you would add more compute resources. And there is more. We know that customers use Postgres and other operational databases for a variety of workloads, including building real-time insights and reporting. AlloyDB delivers up to 100 times faster analytical queries than standard Postgres. And that's with zero schema changes. So no need to move data around. You can build these amazing GraphQL interfaces using Hasura and AlloyDB to create experiences powered by this fast, real-time analytical query directly against your operational databases now. And it does all this while being highly reliable and highly available as well. We offer 99.99% availability for SLA. And that does not include, that not only includes unplanned failures, but database maintenance as well. So you can serve your end users with a higher uptime. And AlloyDB automatically detects and recovers from most database failures within 60 seconds, independent of database size and load, which really means that recovery is not only fast, but it is also very predictable. And hence you can build APIs behind it where you can commit to some sort of higher SLA. Our architecture also supports online instance resizing and database maintenance as well. And the primary instance can resume normal operation in seconds, while the replica pool updates are fully transparent to users, which means that your availability can only increase. And in terms of scalability, the read count can scale horizontally as well, with load balancing across more than 1,000 vCPUs. And of course, the associated storage scales automatically as well due to the scale-out intelligent storage engine. For analytical queries, AlloyDB is powered by a vectorized columnar execution engine that speeds up queries of this nature. And the intelligent storage service provides very low lag read replicas. So you're always querying an up-to-date version of your data. This means now you can run super fast real-time queries on your operational data directly with zero impact on your operational workload. So no schema changes, no additional indexes, and no additional configuration. And AlloyDB delivers these real-time insights just out of the box without having to change much of your configuration. And managing AlloyDB is also very easy, as you spoke about at the start. So we use machine learning and other adaptive algorithms to provide comprehensive database monitoring, troubleshooting, and optimization. AlloyDB features autopilot systems to help both automatically manage and dynamically adapt the database systems to your needs. You no longer have to worry about complex database management tasks such as memory management, vacuuming, and data tiering. AlloyDB automatically addresses them for you. And here's one more thing about AlloyDB. AlloyDB makes it easy for you to build machine learning directly into your applications with intelligent transactions. It is pre-integrated with Vertex AI, our artificial intelligence platform, which means you can create a model in Vertex AI and then call it within a query or transaction. Now imagine building an API on top of that makes the access to machine learning models so much more easier. So here's an example where a payment processor can immediately flag a new transaction in flight as fraud because it's calling a model within it itself. And just putting this behind Hasura deployment as a source of data will only make your GraphQL calls simpler and significantly reduce the latency. Integrating this into Hasura is also pretty straightforward, as all the hard work of heavy lifting has already been done by the Hasura team itself. So you just select the data source as AlloyDB and follow the instructions. And in a few minutes, you have a GraphQL interface powered by a turbocharged instance of a Postgres-compatible database. So far, we saw some great compute options in Google Cloud to run Hasura at scale and the most cost-effective manner. We also saw two great data sources: BigQuery, our petabyte scale serverless database warehouse solution; AlloyDB, our 100% compatible database engine, but turbocharged by reinventing grounds of storage and management layer based on machine learning. But there'll always be things that give you pure joy due to its simplicity yet power. And here's my personal favorite on Hasura: remote joins. What makes it so powerful is that you can seamlessly integrate Google Sheets into your data source along with your existing data sources, hopefully AlloyDB, and create new API endpoints. And this is particularly powerful in instances where you want to do a quick prototype and provide a GraphQL interface that a developer can use to start building a prototype front end or whatever application they're building, while you continue working on downstream APIs. Hope you found the presentation useful and insightful. GraphQL is a very simple but incredibly powerful spec to simplify modern development, but it does have some hard parts. Hasura has taken it to the next level by further simplifying the hard parts so you can focus on building great experiences. Similarly, at GCP, we've taken some of the hard parts out of managing infrastructure and database to bring back the delight of building products and running it and managing it at scale. Thank you for your time and attention. Hope you enjoy the rest of the conference. Thank you for your time.